Hey guys, it's Weber here to teach you your last lesson on quadrilaterals. Yay! So excited. I know you're pumped too because that means the next thing is the test. And I know how much you guys love tests. Anyway, let's continue. All right, so today's lesson is the very last quadrilateral that we need to study, and it is the trapezoid. Trapezoid. A trapezoid is not a parallelogram. It's not a rectangle. It's not a square. It's not a rhombus. It's not a kite. It's in its own little world all by itself. And the one thing, the one property that all trapezoids have is they have only one set of parallel sides. So you'll remember when we talked about a parallelogram that all of the opposite sides were parallel. Well, in a trapezoid, it's just the bases. The bases are parallel, and those bases are the top and bottom. You see how those are parallel, and you see how these other two sides are not parallel because if you were to keep them going, they would cross each other. So the only property that you need to remember about a trapezoid is that there's only one side, one set of parallel sides, and that's the bases. Now, another thing that you need to remember that you already know here is that all four angles add up to equal 360 in a trapezoid. And in a trapezoid, there are absolutely no right angles. No right angles, okay? At least not in this one. You can have what's called a right trapezoid. A right trapezoid would look something like this. In which case there would only be the right angle here and the right angle there, okay? So I guess I shouldn't say no right angles, okay? But there's not four right angles here. All right, so that's your trapezoid. Now let's take a look at some notes, okay? There are two types of trapezoids that we'll look at, a non-isosceles trapezoid and an isosceles trapezoid. Now, that word isosceles is a vocabulary word that we've used before. And remember, the word isosceles means two equal sides. Two equal sides. A non-isosceles trapezoid has no equal sides. Okay? So, properties of a non-isosceles trapezoid with no equal sides is that, first of all, you see how the top and bottom have those little arrows on there? That means that they're parallel. So the bases are parallel, and that's true of all trapezoids. So you see right there, those are bases, and those are parallel. So bases are parallel. All right. And the only other thing that you need to know about a non-isosceles trapezoid is that adjacent angles are supplementary. And remember that that word supplementary means that they add to equal 180 degrees. All right. Now, when I say adjacent angles, I don't mean side by side on the top or side by side on the bottom. What I mean is that this bottom angle plus this top angle will add to be 180 degrees. And then this top angle and this bottom angle will add to be 180 degrees. And that's the only way it works. It doesn't work any other way there. All right? So, next is the isosceles trapezoid. All right? The isosceles trapezoid means that it has two equal sides. Okay? And you can see on this picture that these little tick marks mark the congruent sides. So these are the congruent sides. Those are called the legs of the trapezoid. So the trapezoid has two parts. It has bases and legs. I'm going to go back out to this picture right here. This is a base and this is a base. So the parallel pieces are always the bases, and then the other two pieces are the legs, okay? So a trapezoid has two bases and two legs. And an isosceles trapezoid, the legs are congruent, all right? And that's those two side pieces with those tick marks, okay? So we have that. That's the first property, actually, that the legs are congruent. And you can see that with that congruence tick mark there. All right, the next important thing about an isosceles trapezoid is that the diagonals are also congruent. The diagonals are also congruent. All right, and for us, we know that that means that this piece right here is equal to this piece right here. All right, so also, since these two are equal, notice that that means that this little piece up here is equal to this little piece right here. I'm going to put 2 tick marks there. And then this big piece right here is equal to this big piece right here. That's very important too. All right, now the next property of an isosceles trapezoid is that the base angles are congruent. And what I mean by that, yellow highlighter, what I mean by that is that this base angle right here, this whole angle down here, is equal to this whole angle up here. Those two are congruent. And orange highlighter, this top angle right here is equal to this top angle right here. Now that's only true with an isosceles trapezoid. All right. And then the last thing is that we still know that adjacent angles are supplementary, like the top and bottom angle are supplementary, okay? But opposite angles are also supplementary. And what that means is that one orange angle plus one yellow angle is going to be 180 degrees, no matter how you do it. So this angle, this yellow angle plus this orange angle will be 180. This yellow angle plus this orange angle will be 180. This yellow angle plus this orange angle will be 180. Or this yellow angle plus this orange angle will be 180. So any way you do it, a bottom angle plus a top angle is going to be supplementary. All right, so those are our properties of trapezoids. Now, let's do a couple of these examples and see what we can do. So first, it tells us that angle J is 87 degrees and angle L is 51 degrees, and it wants us to find angle K. Now, the way we do this problem is we know that this bottom angle and this top angle will add to be 180 degrees. So all we have to do is 180 minus 51. And that gives us 29 degrees. So now we know that angle K is 29 degrees. And the same thing is true for 87 and angle M. Those two are supposed to equal 180 degrees. So all we have to do is do 180 minus 87, and that gives us 93 degrees. All right. Next. So for number 2, very similar process. This angle A, 62 degrees, and this angle D have to add to be 180 degrees. So all we have to do is do 180 minus 62, and that gives us 118 degrees for angle D. Who is calling me? Go back over here to number 1. This is 129, not just 29. 129 right there. Sorry about that. All right, and now we go to angle C. When we're doing angle C, we have 31 degrees here. We know that this top angle and this bottom angle have to add to be 180. So we just do 180 minus 31, and that gives us 149 degrees. So that's how you deal with the angles in a trapezoid. And those are both non-isosceles trapezoids. And you know that because you don't have any equal angles in there. All right, now let's talk about another important feature of a trapezoid, and that's called the mid segment of a trapezoid. The mid segment of a trapezoid. Now, the mid segment of a trapezoid is the line that's drawn directly in the middle of the trapezoid and is still parallel to the bases, okay? So our bases here are AB and DC, and we know that because we can see the little parallel marks right there. And the mid segment is drawn in the middle of those two, EF, and it's parallel to the bases. So the first thing that we're going to write here on our properties is that the mid segment is parallel to the bases. It's parallel to the bases. Now, this midsegment does a ton of really cool things in this trapezoid. First of all, it bisects the sides, okay? It bisects the sides, which means this whole side AD over here is broken into two equal pieces. AE and ED are equal. It also bisects the other side, BC, so that BF is equal to FC, all right? And then there's a really cool relationship between the bases and the midsegment. And if you add the bases together and divide by 2, that will give you that midsegment. So our bases are AB and DC. So AB plus DC. So you add the bases together, divide that by 2, and that gives you the length of the midsegment, EF. So AB plus DC divided by 2 gives you midsegment. All right, now let's talk about how we can figure out some of these problems. So in this first one here, it gives us that AB is 14 and DC is 26, and it asks us to find EF. So I'm going to draw a little trapezoid here, and I'm going to draw its midsegment right there. And it says that we're using the above trapezoid, so that means that this is A, B, E, F, D, C. And it tells us that AB is 14 and DC is 26, and it wants us to find EF. Well, all we have to do is add together the bases and divide by 2. So 14 plus 26 divided by 2. So that gives us 40 divided by 2, which is 20. So EF is equal to 20, exclamation mark, because that's really makes us really happy. All right, now let's take a look at the next one. Little trapezoid there. Okay, and again, we're going to use this same trapezoid. So A, B, E, F, D, C. Okay, and it tells us that AB is 7 and DC is 31, and it asks us to find EF. So again, all we do is set that add those together and divide by 2. So 31 plus 7 divided by 2 gives us 38 divided by 2, gives us 19. So EF is 19. I hope you've enjoyed these notes on the midsegment of